Yeah, for self-diffusion in polycrystalline copper with a lattice diffusion coefficient dl, grain boundary diffusion coefficient dgb, and surface diffusion coefficient ds, the correct relationship is. Okay, so it is talking about the diffusion capability or the easiness of the diffusion when we have three types of surfaces. Okay, like suppose you consider this as a material, then you can say that this is the surface, right? So here ds will act. Now next is the grain boundary. Now since material it is made up of different grains, okay, so the diffusion along this grain boundary will be because of this dgb, and this L is the lattice diffusion which will happen inside the lattice, like this is the grain, okay, but this grain right now it is visible on the face, but you consider it in the inside, okay, inside one, and that will act as the lattice, so dl. So guys, we understand that this is the surface, and in the surface the number of broken bonds is very high, okay, so that's why the atoms are more free over there for the movement, okay, so that's why the movement can be very high. So ds should be high. Then what, the next number of bonds where it is more broken, sorry, lesser broken than surface, is the grain boundary, right? In the grain boundary, some bonds are okay, some bonds are not okay, some bonds are tilted, some bonds are not properly fitting. So you can say that dgb. Then the area where the bonds are okay, there is no problem, only some vacancies, some other things can be there. So dl, right? So diffusion capacity in the surface will be higher than grain boundary than d.